Hello friends. Today we have with us the ECT-35D, an earth leakage controller. In this video, we'll understand its working principle, wiring connections, and parameter settings step by step. Let's start with the front panel. Here you can see two buttons, test and reset. Using these buttons, we can check the relay contact operation and also set or reset the leakage current value. On the display, you'll see the leakage current in milliamperes. When the leakage crosses the milliamp range and reaches the ampere range, for example, from 59 milliamperes to 1 ampere, the A indicator LED turns on automatically. This LED here indicates the relay output status. You'll also notice a circular marking on the unit. That's actually the CBCT, core balance current transformer, symbol. In this model, the CBCT is built in, so you don't need an external one. Now, let's talk about its parameters and specifications. On the side, you'll find the wiring diagram. Your three-phase lines and neutral must pass through this inbuilt CT loop. The ECT-35D can measure and detect leakage current from 30 milliamperes up to 3 amperes, which covers most industrial protection needs. Its auxiliary supply range is wide, 100 to 270 volts AC or DC, which makes it suitable for both AC and DC control systems. Now let's move to the wiring setup. We've given line L and neutral N supply connections to the unit. From line, we've taken a short link to the common COM terminal. From the NO, normally open, terminal, we've connected an LED lamp, and the LED's neutral goes directly to the neutral line. To simulate a leakage condition, we've connected a simple test bulb. The phase wire is connected directly to the bulb, while the neutral wire passes through the inbuilt CBCT loop before going to the bulb. So, whenever the bulb turns on, the controller will detect leakage current through the CT and trigger a trip action. Now, let's power on the meter. You'll see 0 on the display, and the relay LED turns on. Right now, there's no leakage in the system. That's why the display shows 0 leakage current. We again have two buttons, test and reset. To check whether the relay output is working properly, press and hold the test button for 5 seconds. The display will show test, and the relay output will switch off. To bring it back, press and hold the reset button, and the system will reset. Now, to enter the settings menu, press both the test and reset buttons together. The display will show pass, asking for a password. The password is 123. After entering 123, press both buttons together again to enter the parameters. The first parameter is the set value. Right now, it's 3 amperes. We'll change it to 100 milliamperes since our demo bulb is just 500 watts and we want it to trip easily. Press both buttons again. Next, you'll see the delay time. By default, it's 1 second. You can increase or decrease it. We'll keep it at 0 seconds for instant tripping. Press both buttons again. You'll get relay fault mode. It's currently set to off. This means the relay will de-energize, turn off, when a fault occurs. If you set it to on, the relay will energize during a fault, useful when you want to trip an MCCB shunt or other interlocks. Press both buttons again. The next option is mode, manual or auto. We'll select manual mode so that resetting is done only when we press the reset button. One more option you'll see is password enable or disable. We'll keep it disabled for quick setup access. Press both buttons together again to exit the menu. Now, let's test it live. We've set the delay to 0 seconds. When I switch on the bulb, the leakage current is immediately detected, and the controller trips the relay. You'll see the trip indicator LED turn on, and the relay output LED turn off. The display also shows the actual leakage current value. For example, 434 milliamperes. When the bulb turns off, the leakage drops back to 0. Since we're in manual mode, we now press reset to clear the trip condition, and the relay turns on again. Now, if your system uses an MCCB shunt or you want the relay to energize on fault, go to settings again. At relay fault mode, change from off to on, and exit. Now, when leakage occurs, for example, when I turn the bulb on again, the relay LED turns on, showing the relay has energized for tripping. The display again shows the leakage current value and the trip indicator appears. To reset it, simply press and hold reset. Everything returns to normal and the relay LED goes back to its standby state. So that's how the ECT-35D earth leakage controller works. If you found this explanation helpful, don't forget to like, share, and subscribe for more videos on industrial control and automation.